Welcome once again to a time value of money video. Let's continue now. Let's look at problem number 5. You borrow $20,000 at date 0 to buy a new car. Terms of the loan call for an annual interest rate of 12% and 5 years of monthly payments, with the first payment due 1 month from today at date 1, today's date 0. What will be the size of the monthly payments on this fully amortized fixed rate level payment loan? Okay, that fully amortized means that when you make your last required payment, you will owe nothing. Fixed rate means the interest rate will not change over the life of the loan. Level payment means the size of the payment does not change over the life of the loan. It's the same payment every month. Okie dokie. So, in order to solve problem number 5, let me just start by doing a cash flow date line. At date 0, it's like we received $20,000. Of course, we immediately trade it for a car. But then, if that bothers you, remember, if we didn't value the car as much as we valued $20,000 in cash, then we wouldn't exchange the cash for the car. So this is probably a step up in utility, so we're fine. So at date 1, we make a payment. I'll put a minus sign in front of it. Cash flow minus P. At date 2, minus P. Date 3, minus P, all the way out to date 60, minus P. Why date 60? Well, 5 years of monthly payments, 5 years at 12 payments a year is 60. It's important that we realize that the frequency of the cash flows is what defines the number of periods we use in our analysis. It's also true that since the interest rate is 12%, it's a stated rate, annual, that we have to divide that by 12 to get 1% as our monthly rate. So for us, the appropriate value of R will be 1% or 0.01 in our analysis. So again, if it's a 12% 5-year loan, in order to solve it correctly, the monthly rate is 1% and the number of payments is 60. Can't forget that. Now, so we're going to use the application formula number 4, which says, present value of an annuity equals annuity cash flow times present value interest factor for an annuity. In this case, our R value is 0.01 as explained, and our N value is 60 as just explained. And the present value of our annuity, well, in this case, it's the $20,000. And the annuity cash flow is the payment. I'll just call it P. And I'll put in the computational formula for the PVIFA. It's 1 minus 1 over 1.01 to the 60th power divided by 0.01. I go over this in detail. I go over PVIFAs in great detail in an earlier video. Make sure you know them very well, especially if you're a student in one of my classes. Very important. Okay. This just leaves us with the obvious observation that the payment is going to be equal to 20,000 divided by the PVIFA. Right? And generally speaking, this will be the case. Keep in mind the size of the payment for this type of loan, which is a fully amortized fixed rate level payment loan. Okay, the size of the monthly payment is going to be the loan amount divided by the appropriate PVIFA. That's always going to be the payment amount. Keep that in mind, very important. And by the way, let's think for a second, what's the size of the PVIFA going to be? Let's look at this interesting issue. PVIFA versus N, where N is the number of payments. Well, let's think about what a PVIFA is. We know a PVIFA is a sum of PVIFs. What do we know about PVIFs? They're always less than 1. So we've got in a PVIF, we have, the sum for I equals 1 to N. In the PVIFA, rather, we have a sum for I equals 1 to N of a bunch of PVIFs. Each one's less than 1. Well, it's obvious we have N times numbers less than 1 have to be less than N, right? So a PVIFA will always be lower than its relevant N, its own N. Keep that in mind. A PVIFA is always less than its own N. Okay, so that's number 5. Okay, so that was relatively easy. Let's go on to problem number 6. Very similar. If we take out a traditional mortgage in the amount of $1 million with an annual interest rate of 9.6% and 15 years of monthly payments, what will be the size of our monthly payments? Well, that's easy. It's the same problem again, just couched in terms of a mortgage. Okay. A mortgage is a loan that if the borrower were to default, the lender would have access to taking ownership of the property on which the money was lent. And if it's purchase money only used, as I understand it, nothing else. All they can do is take the house back. They might try to hurt your credit rating, but they can't come after other personal assets. I believe check with an attorney to be sure. Laws change all the time. Okay, so number 6. So this is easy. Once again, we use application formula 4 that says present value of annuity equals annuity cash flow times the present value interest factor for an annuity. In this case, our R is 9.6% divided by 12, which is going to be 0.8%, or 0.008 decimal. And our N value will be 15 times 12 per year, or 180. Okay? So, that's our formula. Now, let us plug in the relevant values for this problem. Our PVA, our present value of annuity, is the $1 million. Okay? And the annuity cash flow is what we're solving for. I'll call that P. And the PVIFA, of course, is going to be 1 minus 1 over 1.008 raised to the 180th power, all divided by 0.008. Again, the very important, the details on the derivation of this were provided in an earlier video. Just look it up. It's on the playlist here. Okay, so that's the formula. So, of course, it's obvious. P is equal to 1 million divided by the PVIFA. And again, be careful when you are calculating. It's a 0 there. By the way, let me just fix that quick. Be careful when you're doing these calculations here on your calculator. And by the way, just make note again so you remember, this is equal to the loan amount divided by the PVIFA, the appropriate PVIFA, which will always be a number that's less than N. And in this case, when you do the arithmetic, the answer ends up being $10,502 and about 67 cents. That's your monthly payment. And I think that's enough for this video. Thanks for watching.